Which of the following is the order of heat of hydrogenation of the following compounds? So we need to find the order of heat of hydrogenation. And we know that heat of hydrogenation is inversely proportional to stability. If we can find the stability order of these compounds, then we can find the order of heat of hydrogenation by just reversing it. And all of these are cyclopropane systems, and therefore the stability will depend on two factors. The first one is ring strain. Cyclopropane systems are strained systems, and we can compare the strain of these three given rings. So we can say which one is more strained, which one is less strained, and thus we can compare the stability. And the second factor is substitution. As we can see, the given compounds contain double bonds. So we can use that as a parameter, substitution. More substituted alkene will be stable. And we can use that parameter to determine the stability. So let's take the case of our first compound. This is our first compound, and as we can see, these two carbons are sp2 hybridized. sp2 hybridized means the bond angle should be approximately 120 degree. But since these bonds are present in the cyclopropane system, the bond angle will be only 60 degree. So 120 to 60 degree. That's a great angle strain. Therefore, we can say that this particular system is strained. Now, take the case of our second compound. This is our second compound. And as we can see here, these two carbons are sp2 hybridized. The bond angle should be 120 degree, but only in this particular place, the bond angle will be 60 degree. It will be 120 degree for the other part. So among the two carbons, only one particular carbon will be strained due to the change in bond angle or the deviation from ideal bond angle. So comparatively, this is less strained. Now take the case of our third compound. This is our third compound, CH3 here. And here we can see that both the sp2 hybrid carbons are strained because the bond angle is only about 60 degree. So this is also a strained system. And from this, the stability order will be 2 is more stable than 3, which is approximately equal to 1. We cannot say whether 3 or 1 is more stable. So how to determine that? For that, we will have to consider substitution. While considering substitution, we can see that for the first compound, this is our first compound. The alkene is disubstituted. There are only 2 substitutions for this. But take the case of the third compound. This is our third compound. As we can see, there are 1, 2, 3 substitutions. Therefore, this will be more stable than a first compound, and therefore we can write the order of stability will be 2 greater than 3 greater than 1. This will be the order of stability. But we want the order of heat of hydrogenation, which will be the reverse of this. Therefore, we can say the order of heat of hydrogenation will be 1 greater than 3 greater than 2. So that will be the answer.